Let's just spend a little bit of time talking about what electricity is and how it's generated. This is another lecture that if you remember this from a high school physics class, you can probably skip it. If not, I will try and do my best to give you a basic understanding of the topic as I understand it. So electricity is electrons that are flowing. And so we said it's a form of kinetic energy. And so this is the flowing of electrons moving. Electrons, you probably remember, are those really tiny negatively charged subatomic particles, which means that they're smaller than an atom because they're just one part of an atom. Atoms are the smallest building blocks in nature because they're the smallest thing that does it. That's just, that designates an element. So atoms have a positively charged nucleus that has protons and neutrons in it, and the electrons circle around that positively charged nucleus and give the atom an overall net zero charge. If you're looking at an atom, this is a diagram of an atom because obviously you can't see an atom with your naked eye. The nucleus, we said, is positively charged because it has protons and neutrons in it, and then the electrons are circling around it. What you find is that the electrons that are the closest to the nucleus are held more tightly to the nucleus. They're attracted more to it because as you move away from that inner shell to the outer shells, there's some shielding that goes on where the other electrons that are in closer to the nucleus are able to experience that charge more than the electrons that are in the outer shells. And as a result, these electrons that are in the outer shells are able to come loose or unbound more easily, and then they can, the loose electrons can then travel and conduct electricity. You do encounter electricity in your everyday life, even if you're outside and you're not anywhere near a power outlet. So static electricity is one example. If you rub a balloon on your head, you can stick it on the wall. That's because when you rub that balloon on your head, you're rubbing some electrons from the balloon onto your hair, and then the negative charge is going to make your hair stand up. So when you do that, you get that crazy hair, and that's what's happening. With lightning, that's the transferring of electrons from a cloud to another cloud or from the cloud to the ground, and so it is the movement again of electrons. Okay, so the next step then is to try and discuss how electricity and magnetism are related, and the reason we need to discuss that is because that's very critical for how a turbo generator or turbine runs, and so just bear with me on this a little bit. As electrons spin, they travel around the nucleus of an atom. If you remember that diagram of the atom, that creates a tiny magnetic field. And in most atoms, the motion is really random, and so there's not any kind of net field around the atom because they're all spinning and moving in slightly different directions. But when you have a magnet, so only some materials are magnets, only ferromagnetic materials are magnetic. And these materials, the molecules are all arranged such that the electrons are all spinning in the same direction, and that creates an overall magnetic field. So the magnetic field is shown here in this diagram, and you might remember from your high school physics that field extends out from the North Pole and then comes around to the South Pole. And Earth has also a magnetic field around it, and that's why they refer to us as having a north and a south pole. And then there's that magnetic field around Earth, and that actually helps shield us from certain types of energy, so it's a good thing. Just as electrons create a magnetic field, whenever the electrons are subjected to a magnet, that can cause them to move. So they can create a field, and then that field can act on them and make them move. As you change the direction of a magnetic field, so if you move a magnet around, then this can push or pull electrons to get them to move. So turbo generators or turbines take advantage of this phenomenon, and they basically they all run on the same basic premise. So in steam-driven turbines, you have coal or oil or nuclear power. All of them are being used so you're combusting the coal or the oil, or you're harnessing the energy from the nuclear, from uranium, which is your fuel, and you're using it to superheat water to create steam that's under very high pressure. And then when you release that steam through a small pipe and it hits the turbine, it's going to make it spin around, and that's attached to a shaft which goes into a motor, and it causes that shaft to spin around. Similarly, with hydropower and wind, instead of burning something in order to make something spin around, the wind is being used to spin a turbine, or with the dam, with this hydropower, as the water flows through the dam, there's a set of wheels or turbines down here, and the water flows through them and pushes them in a circle. So if you could get inside of a turbo generator, which you can, some of them are big enough, there's that spinning part, it's called a rotor, that's that shaft, spinning part, and it spins inside of or around what's called the stator, and the mechanical energy that's driving that rotor, that's making it spin around, is coming from the turbine. So we said it can be powered by steam when you combust something, or it can be powered directly by the wind that's causing it to spin around. So in this case, the rotor is spinning around a coil of copper wire, and the copper wire is a conductor. Okay, so there's the wire coming out. As it spins around, then the magnetic field is changing, and because there's spinning magnets inside of here, so here's some magnets, so it's spinning around, these magnets are moving, and they're changing the direction of the magnetic field, and that's making the electrons are always going to flow perpendicular to the direction of the magnetic field, so the electrons are flowing out of the wires at the end. It's important to note that while most technology, we're still kind of using old technology to generate electricity when we talk about turbo generators, but not all electricity comes from a turbo generator. So solar photovoltaic cells do not use turbo generators in order to create an electric current, and there's a video posted that tells you exactly how they work and how they generate electricity. Once electricity is generated, then you have to get it from the electricity power plant to a place where it can be used or consumed. Across the United States, there's a network of 160,000 miles of high voltage transmission lines that connect power plants to the place in which the electricity is consumed. So they travel from the power plant, they go through a transformer that increases the voltage, then they get carried over the transmission lines, and when they have a higher voltage, less of the electricity is lost as it travels through the lines. That's why they step it up in voltage. And then when it gets to the neighborhood where it's going to be used, there's another transformer that helps to decrease the voltage, so that it doesn't fry the electric lines in your house. And then the electricity comes from these power lines into homes.